Let's go and visualize this. Let's consider a really simplified version of the example we just talked about. We generated a force model in order to predict the unknown data from the employees who did not respond. Let's apply this model to a particular employee who lives 1.5 miles away from work to illustrate how the force model will work. Remember, the trees here are simplified to demonstrate the concept. For the first tree, a random sample of the data is taken and a tree is created from it. Here's the tree. Since the employee we are trying to predict lives 1.5 miles away, this tree would predict that she has a 50% chance of driving to work, 30% chance of taking public transportation, and a 20% chance of walking or biking. Now another tree is generated from a different random sample. Here's that tree. In this tree, our employee is predicted to have a 20% chance of driving, 30% chance of using public transportation, and a 50% chance of walking or biking. A third tree is generated from a different random sample. Here is that tree now. In this tree, our employee is predicted to have a 30% chance of driving, 20% chance of using public transit, and a 50% chance of walking or biking. In a force model, hundreds of trees like this would be created, and then the results of each would be averaged to make a prediction. Let's average based off these three trees to make a prediction. So driving is 50% plus 20% plus 30% divided by 3, so it's 33% likely to be driving. The public transit was 30%, 30%, and 20%. When you divide that by 3, that's 27% likely to be public transportation. And then walking and biking had a 20%, 50%, and a 50% chance divided by 3, which equals 40%. So you can see that if we had only used the first tree, that because of overfitting, it may have had a very different prediction than the forest model. It would have predicted most likely our employee drove. But using a forest technique, it predicted that she most likely walked or biked.